Two charges q and minus 3q are placed fixed on x-axis at separation d. Where should a third charge 2q be placed such that it will not experience any force? Also calculate potential energy of the system. What we are solving for the position of a third charge 2q where it experiences no force and the total potential energy of the system. So we need to place a third charge 2q at a position x such that the net force acting on it 0. So what are the two possibilities? Two possible position for charge 2q. The first possibility is between q and minus 3q. So if we place 2q between q and minus 3q, the force due to q will repel 2q to the right direction and the force due to minus 3q will attract 2q to the left. Therefore, it cannot be at this region as the net force will not be 0. Next possibility, we can place this to the right of 3q and to the left of charge q. What will happen if we place 2q charge this side of minus 3q charge? The magnitude of 3 is greater than that of 2q and there will be attractive force. So in this case the net force will not be 0. So we have to consider a position to the left of q. So we will place 2q at a distance x to the left of charge q. So we will place charge 2q at the point P. So on 2q, force due to q is to the left and due to minus 3q is to the right. Let the distance of third charge 2q from charge q be x and the distance of the third charge 2q from charge minus 3q is x plus d. The net force on 2q to be 0, the forces due to q and minus 3q must balance. That is F due to PA must balance F due to PB. K into Q into 2Q divided by x square must be is equal to K into minus 3Q 2Q divided by x plus d whole square. Q will get cancelled out and 2 also will get cancelled out here. So if you simplify this equation, so 1 divided by x square will be is equal to 3 divided by x plus d whole square. Cross multiply the two equation, what you get? X plus d whole square must be is equal to 3x square. The previous equation is x plus d whole square. You can simplify into a plus b whole square, a square plus 2ab plus b square. If you simplify that, you get x square plus 2xd plus d square, which is equal to 3x square, or you can simplify this 2x square minus 2xd minus d square, which is equal to 0. So this is a quadratic equation. So you have to use the quadratic equation to solve this. So minus of minus 2d plus or minus square root of minus 2d square minus 4 into 2 into minus d square divided by 4. So 2d plus or minus 2d square, right? Now what you get? 4d square minus into minus. So it becomes plus 8d square divided by 4. Solving, you get 2d plus or minus square root of 12d square divided by 4. So I can write this as 2d plus or minus root of 4 into 3d square divided by 4. So I can take the 4 outside the bracket, the square root. So root of 4 is 2. So I get it as x is equal to 2d plus or minus 2. D square also I am taking it out. 2d root 3 divided by 4. If you simplify, 2 will get cancelled out. So what you get? d plus or minus d root 3 divided by 2. That is the x value. Therefore, x is equal to d plus or minus d root 3 divided by 2. Since x must be positive, that is the charge 2q cannot be between q and minus 3q. So, we take the positive root. We also need to calculate the total potential energy of the system. So, the total potential energy of the system is the sum of the potential energies of all pairs of charges. So, let us take U as the potential energy. So, U is equal to K into the charge Q due to minus 3Q divided by D, and the charge K into Q into 2Q divided by X, and the final charge K into minus 3Q into 2Q divided by X plus D. So now substitute x is equal to d into 1 plus root 3 divided by 2 in the above equation. Potential energy K into minus 3Q square divided by D plus K into 2Q square divided by D into 1 plus root 3 by 2 plus K into minus 6Q square divided by D into 1 plus root 3 by 2 plus D. If you simplify this, so U, which is equal to K into minus 3Q square divided by D plus 2 I am taking to the numerator. So, K into 4Q square divided by D into 1 plus root 3 plus D I am taking as a common factor outside. So, K into minus 6Q square divided by, if I am taking D as a common factor, so 1 plus root 3 divided by 2 plus 1. If we further simplify this, U is equal to K into minus 3Q square divided by D plus K into 4Q square divided by 1 plus root 3 plus, see, I am taking an LCM here. So, 1 plus root 3 I multiply by 2. So, 1 plus root 3 plus 2 divided by 2. 2 I am taking to the numerator. Okay. So, what do you get? 2 into 6. So, K into minus 12Q square divided by 1 plus root 3 plus 2. So, it becomes D into 3 plus root 3. Here we are going to rationalize the denominators. So, what you get? K into minus 3Q square divided by D plus K into 4Q square. So, we are multiplying and dividing by root 3 minus 1, and in the last parameter we are multiplying and dividing by 3 minus root 3. What you get? So, you get the equation as this. If you further simplify this, you get an equation K into minus 3Q square divided by D plus K into 2Q square into root 3 minus 1 divided by D plus K into 2Q square 3 minus root 3 divided by D. So, now combine the terms. So, what do you get? So, U, which is equal to KQ square by D, I am taking as a common factor, KQ square by D multiplied by minus 3 plus 2 root 3 minus 2 minus 6 plus 2 root 3. If we simplify this, KQ square divided by D into minus 11 plus 4 root 3. That is the kinetic energy of the system.